Okay, group, welcome. We're going to look at rearranging formulas. We've looked at how to solve using formulas. Here's a good example of a formula that's a little bit involved, has Celsius and Fahrenheit temperature. And tomorrow in class, we're going to be doing an activity where we're going to be taking this formula and coming up with strategies for isolating Fahrenheit if we know Celsius, and also coming up with simple ways that we can convert from Celsius to Fahrenheit using mental math. I want to just use this formula as an example that introduces inverse operations. Those are operations that undo each other or reverse each other. It's helpful to have an arrow diagram that we can use where we start with one of the variables and we're doing certain operations on that to produce the value of the other variable. A good example would be starting with a flat tire. You know, the flat tire is on the vehicle, and the first thing we do to the tire is we place the jack under the vehicle somewhere securely on the vehicle. We place the jack, then we loosen the lug nuts from the tire, then we raise the car, then we remove the lug nuts, we finally remove the flat tire, and then we reverse the process to get back to what we started with. So when we think about all these things we've done maybe on our variable f to get c, we could ask, well, what if we wanted to get back f? What if we wanted to isolate f? What would we have to do? In the changing the flat tire example, we would do everything that had been already done in reverse. We would replace the flat tire, we would tighten the lug nuts, we would lower the car, we would tighten them further, and then we would finally remove the jack from under the vehicle. So it's a very similar idea here. When we look at what's being done to Fahrenheit, first we're subtracting 32, then we're multiplying by 5, then we're dividing by 9. All those steps convert the Fahrenheit into the Celsius. If we have the Celsius and we want to get back the Fahrenheit, we would start by doing the opposite of each of these steps. And we'll look at that in class tomorrow. Okay, so just to introduce this idea of an arrow diagram, and we can think about the operations that are pairs or matching operations, an operation and its inverse. We have here addition, subtraction, multiplication, division, square and square root, cube and cube root. And I've also included a operation which is simply the value of a variable and the reciprocal of that as being inverses. And sometimes that's a useful operation to carry out, is to take the reciprocal whenever we're trying to isolate variables. So you have some strategies which are also provided here. I'm going to go through some examples here to demonstrate these strategies, that sometimes isolating the variable then substituting the numbers is more convenient than substituting the numbers and then solving, particularly if we have to substitute lots. If you have to calculate several times, it's better to isolate first and then figure out an expression that allows us to just put in numbers over and over again. If we're only having to rearrange the formula maybe once and it's a very difficult formula, it might be easier to substitute the numbers first, particularly if the numbers are easy to work with, and then rearrange afterwards. Okay? So I'm going to go through some examples here in your textbook. First one is using a formula that involves simple and compound interest, or simple interest rather. The second one is volume related to length, width, and height. We have Ohm's law formula connecting current, resistance, and voltage. So these are formulas that you may or may not have seen before. Isolating P from the simple interest formula is pretty straightforward. The only thing we're doing to P that produces the amount of the investment is adding I. So to isolate P on its own, which is the instruction here, we're going to simply take both sides of the equation and we're going to subtract I. We're going to do the opposite of addition. So it's just really a matter of identifying the operation that's performed on the variable that we're trying to isolate, and then just do the opposite of that. Okay, and we've shown this lots before throughout this course, so this is just making a little bit more formal about what the pairs of inverse operations are. So if we look at B, again to look at isolating H from that formula, well, what's being done to H? Well, it's being multiplied by LW. You can think of it as multiplying by L and multiplying by W, but it's being multiplied by LW. So the opposite of that would be dividing by LW, and that produces H on its own. So H would be the volume divided by length times width. And the last one here, Ohm's law formula takes the voltage and it divides it by R, the resistance, to get the current I. And so to isolate voltage, we would do the opposite of dividing by R, which would be multiplying by R. And that's what's shown here. Do the same thing to both sides. That's the only thing we have to ensure is part of this process, is we're doing the same thing to both sides, and that is going to produce our value for the voltage. Example 2 has us converting from degrees to Fahrenheit. In this case, we'll do this in the investigate, so I'll skip over this one for now. We can come back to example 2 in class. Let's have a look at example 3. Solving problems involving power. So here we have the area of a circle. We have another formula which involves the volume of a sphere. And here we're being asked to isolate for the radius in part A, determine the radius, and also in part B, determine the radius. So if we look at the summary here, powers and roots are inverse operations. So to undo squaring, we take the square root. To undo cubing, we take the cube root. And we'll learn about exponent laws lots in this chapter, but in general, the inverse of the nth power is the nth root. So if we want to undo the fifth power, we would use the fifth root. So in part A, let's draw our arrow diagram here. Starting with the radius, we're squaring it, we're multiplying by pi, and that produces area equals pi r squared. If we want to isolate r, we're going to take the value of A and divide by pi, which is the opposite of multiplying by pi, and then we're going to take the square root, which is the inverse of the square operation. And then once we've done that, we can substitute in our values. So that's the easy part, substituting in the A equals 5, pi is the constant. We can solve for the radius from that. The margin notes show you how to do this on your calculator. Part B, this is the formula for the volume of a sphere, which takes the radius, cubes it. Okay, that's the exponent 3. Multiplies that by 4 pi and divides by 3. And that gives us the formula for volume, which is 4 pi r cubed all over 3. So if we want to reverse all those operations, the first thing we should do is multiply by 3. Then we would divide by 4 pi, and that would produce the value of r. And that's shown here. The final result would be that R would be 3, which is the volume that we were given in this question. And that's substituted at the beginning. So that strategy of substitute and then solve is shown here. So take the volume, divide by 4 pi, take the cube root, and we get the radius. And that's the radius of the Nerf ball would be 0.62 meters. Okay, we can ignore this here. Go back to our assigned questions, so you'll have this handout to fill in the inverse operation pairs, and then you'll have some time in class to work on identifying operations for certain questions, and then solving from a pair of questions. And then the feedback problem for this section is either 14 or 16, page 356 or 357. Okay, I'll see you in class tomorrow.